Hello, this is CSC260, September 2015, Review Exam 1, Question 3. Now, in this case, we're going to design a circuit with logic gates that takes a 3-bit 2's complement number and outputs 1 if its absolute value is prime. That is, since 3 bits numbers can represent from 3 to -3, that's going to be 2, 3, -2, -3. So, with this kind of thing, I always like to create a little truth table. So we're going to write, this is going to be sort of a fancy truth table. We're going to start with the decimal number, then the sign bit, the 2-bit and the 1-bit, and the output. That's what we're going to build a table saying. Okay, so this is just a beginning. This is just to organize our thoughts on how this thing. So we'll start with -3, which in 2's complement is going to be 0, 1, 1. We invert it, it becomes 1, 0, 0, and we add 1, it becomes 1, 0, 1. So this is going to be 1, 0, 1. And the output is 1 for this, because its absolute value, there's 3, is prime. Then we're going to have -2, and it's -3 plus 1. So that's going to be 1, 1, 0. And that's output is also 1. Then we're going to have -1, and -1 is always all ones in 2's complement. And the output is 0. Of course, 1, the absolute value is not prime. And then we have 0. Okay? And that one is going to be all zeros. And that's, again, 0 is not a prime. Now, we're going to have 1. This is going to be a little more familiar to you. Okay, 0, 0, 1. And that's also 0. And then we're going to be 2, which is 0, 1, 0. And that is a prime. And 3, 0, 1, 1. And that's also a prime. I'm not going to represent 1, 0, 0, because I don't really believe in that number. Okay, so that is our table that defines our 3 inputs and our output. Now, can we see any patterns in this? Well, okay, if the sign bit is 0 and the 2-bit is 1, then our output is 1. So 0 and 1 make 1. And then, if the sign put is 1, and the 2 and the 1 exclusive OR, right? If we, either the 2 is 1 or the 1 is 1, then the output is 1. So, I'm going to build the circuit based on that. So there's going to be 3 inputs, and let's set those guys up. So now I need some ink. Okay, and I'm also going to scroll down a little bit. Oh, it doesn't want to give me scroll down. Okay, so here it is. S and 1 and S, oops, 2 and 1. Okay, so what I'm going to do is, so one of the things I said I'm going to do is, and I just lost my ink. Okay, I'm going to grab not S. For some reason it doesn't like. Good go. Is not S. And here's 2. You're going to jump over the 1, which is going to go down here. Okay? And so, if it's not S and 2, that's will. So I've just implemented this part. Now I'm going to take 2. I'm going to make an exclusive OR for 1 and 2. And then I'm going to, give me my pen back, take the sign bit and that in. So this is, so this guy, okay, so, and then these 2, and I've just implemented these 2. And then I'm going to OR those 2 together, and voila, that should give me the logic I'm looking for. So, let me just, this is not S and 2. That's what this guy is. This is 1 XOR 2, and this is S and 1 XOR 2, and this guy is out. And there is the answer. It was easier than I thought. Always good.